again, and this is part 2 in our two-part series on refrigeration on a small sailboat. Last time I narrowed down our fridge choices to this Isotherm 3251 system. It's pricey, but a very efficient low-power system, and from what I could see from various forums, dependable. Some have expressed concern about keeping the through-hull clean, but again, forum discussions don't seem to indicate this is much an issue. The key power savings with the system is that there's no fan or pump needed to help cool the refrigerant in the heat exchanger. One thing, though, concerning me is this large through-hull. It's considerably larger than what I have under the galley sink right now. I think this diameter is about 2.5 versus the 1.5 down there under the galley sink now. I'm not thrilled about drilling a large hole in my hull. This is all new territory to me, but however, as you'll soon see, it went along smoothly despite some surprises. I purchased our Isotherm 3251 through Seabourn Marine and Marine Warehouse in Florida, and as their prices were much lower than anyone else I found, it was well packed and arrived in great shape. If you can wait, you'll probably find lower prices near Christmas, and that goes for most sellers. I got acquainted with the 3 installation manuals, one for the through-hull heat exchanger, very short, then 2 big volumes, one on operating the fridge and digital display, and the other was for the compressor, mounting, wiring, connecting the coolant lines. And the volumes are thick because the instructions are repeated again and again in 9 languages. There's something like 10 pages of instruction you'll need to read in your particular language. I don't know why they couldn't have indicated page numbers for each large manual, but what I've done is on the covers indicated what page I need to avoid having to repeatedly dig through the manuals to find the English sections. My plan for installing the system is to install the cold plate first, and then run coolant lines from it behind the cooking stove and then over to the galley sink cabinet where the compressor will be. Then I'll install the digital display controller nearby in the galley sink area, and then run a 12-volt power line from the circuit breakers down to where the compressor will be. Remove the old through-hull and then install the through-hull heat exchanger. Then mount and wire the compressor and connect the coolant lines. And then at last attach the ball valve to the through-hull and install the sink plumbing, since these last items will be in the way while working on the compressor hookups. Oh, and one other thing. I'll apply the adhesive to the through-hull and install it after I verify this system works. Okay, so let's head over to the icebox and install the cold plate. I'll clear out the cardboard that I used to plan out shelving for the organizers that I showed in the last video. And now I'll center and then mount the cold plate high on the aft wall of the icebox with 4 number 10 panhead stainless screws. Estimating a distance from the cold plate to avoid sharp bends in the tubing, I was over far enough to drill a 1-inch hole in the aft wall for the cold plate tubing to go through that will go on to the compressor. Looking in the hole, I found about 4 inches of spray foam insulation in the wall. That's a good thing. Then I ran tubing through the wall along with the wire to the thermistor. That's the temperature sensor. I mounted the thermistor at the top of the back wall, thinking that would help me keep the whole fridge at or lower than the temperature measured there. Likely to be the warmest place in the icebox, if that is farthest from the cold plate. For some reason, Isotherm gives you an incomplete housing for the thermistor, so I used the other digital display option housing in the kit for the thermistor. The hole to the left of the cold plate is much larger than the 1/4-inch tubing, and that's to allow passage for the connectors. I'll need to fill that gap to avoid moisture getting into the insulation. And Isotherm does give you a white lump of malleable putty like substance to fill up that gap in the wall. I drilled a hole in the aft wall behind and alongside the oven to pass the coolant tubing and thermistor wire to the area under the galley sink. Next, I installed the digital display. I'd like it to be in the galley area, but out of the way and up here near the cupboard near the bananas seems best. From under the galley sink where the compressor will be, I drilled a hole up into the cupboard. I then passed through the modular connector that connects to the digital display to that of the electronics module on the compressor. The mounting screws for the display housing Isotherm gives you are soft, and I lost the bite on the first Phillips head, so I replaced them with some of my own. Next, I put in a new 12-volt 15-amp breaker, and I ran about 6 feet of Anchor 14-2 wire from it to down where the compressor will be. The wire down there near the compressor will terminate to a waterproof blade fuse housing next to the compressor, and I'll have a 10 or 15 amp breaker down there. Since wires from the back of the panel drop down through a common cable hole behind the panel to an open area that connects to under the galley sink, I don't need to drill any holes. I just need to secure this wire to the walls. At this point, I could install the compressor, but that looks pretty straightforward. I'd better bite the bullet and take on the job I've been most nervous about, and that's cutting a 2.5-inch hole in my boat under the galley sink. This will be also easier without the compressor in the way. I'll start by disconnecting the galley sink plumbing that goes to the through hull, the old through hull. Following suggestions in the Isotherm manual, I hammered in a 1-inch plug into the old through hull and sawed off that plug flush with the through hull. The old Bronco bronze through hull had also 2 through hull bolts at the flange. I removed those. Next, I grabbed the 2.5-inch hole saw, centered the bit on the plug, and in minutes cut through the fiberglass hull. Fortunately, the hole saw was just big enough to completely surround the old through hull, so no need to take that old through hull apart. Through hull. Now I got to clean up this with the backing plate, and I'll have to grind that, get it down to fiberglass. I'll probably have to address this issue though. Varying hull thickness. It varies from about 3/8 inch to about 1/2 inch. Thinner dimensions closer to the keel. Problem is, it would mean that when I tighten the locking nut from inside the boat, it'll introduce a pitch on the new through hull such that it will not be perpendicular. For the original, smaller through hull, the change in pitch might not have been much of an issue, but I think it is for me now. I'll show you the solution to this problem after I prep the area around the hole. I scraped away the old plywood and adhesive. Then I drilled out the old flange bolt holes. Cleaned and sanded the area inside and out down to fiberglass. Then I cleaned the area with acetone. And finally, after that dried, applied a coat of epoxy to seal the fiberglass. I filled the old bolt holes with thickened epoxy, blocking the outside surface with pieces of acetate plastic. I did a dry fit with a new through hull. And as expected, when tightening the locking nut, it introduces a tilt due to the varying hull thickness. And I can also rock this through hole back and forth a little. Also allowing for that wobble is that the through hole is a metric diameter and the hole saw is 2.5 inch. So I have something like 1/8 of an inch or larger in gap between my through hole and that hole. I also checked on the hull curvature in either direction. Fortunately, it's minimal, so not a factor in this fit. My solution to the uneven hull thickness was to make a backing plate that I'll apply with a pitch. To start out, I cut a donut-shaped backing plate out of 1/4 inch G10 board. I used a 5-inch hole saw to heavily score the G10, not cutting through it, and then I cut out the center with a 2.5-inch saw. Then I used my bandsaw to cut through the remainder of the G10 to get a 5-inch diameter outside diameter hole, and then I rounded off the edge with a rasp file. I could have left this plate as a square, but corners don't do much for support, and it'll look a lot nicer without them. I did a dry fit again now to see how this would work out. I put the donut in place and loosely screwed in the through hole with the locking nut and put a couple of plastic door shims under the G10 plate at the lower end nearer the keel to help level it. It did get rid of the wobble, and now it seems a secure fit. Sorry, I lost a picture of this. It all looked good, so I removed everything. Next, I scuffed up the G10 and the hull lightly with sandpaper, and I cleaned it with acetone. I inserted the through hull in G10, but suspended the through hull in the hole and wrapped it with a thin layer of acrylic, these plastic strips I mentioned earlier, to help prevent the epoxy from getting on the threads. Next, I dabbed a generous layer of thickened epoxy around the through hull under the donut. Next, I put down the G10 donut and lightly screwed down the locking nut on the through hull, checking that the wedges hadn't moved and also that the plastic was still in place. I also added a strip of acrylic sheet between the epoxy and the door shims. I then tightened a little harder on the nut to squeeze the epoxy into gaps between the through hull and hull. I cleaned off excess epoxy around the donut, inside and outside around the through hull. The next day I removed the through hull. I did get a little epoxy on the threads, but I was able to easily break it with a little heat from a heat gun. Perhaps I should have used wax instead of acrylic plastic sheets, as they may have bunched up, allowing some of the epoxy to get to the through hull. I sanded off excess epoxy around the G10 plate donut, and after removing the shims, I filled the void with thickened epoxy. I also reduced the new hole's diameter slightly by squeezing thickened epoxy between the through hull and this piece of 2.5-inch PVC pipe, also covered with acrylic plastic. The nail holds this piece in place perpendicularly. The next day, after removing the PVC pipe section, I checked for voids in the hole between that PVC pipe and the hull and the G10, and I sanded the hole smooth. I also applied clear epoxy over the sanded area around the hull on the hull. Inside the boat, I sanded off excess epoxy and then I painted. Here, I'm rechecking the dry fit assembly again, and it looks good. I'll come back later to install the through hole permanently, as I mentioned earlier. But first, I want to make sure the refrigeration system works. Okay, now it's time to attach the compressor to a wall under the galley sink. I find the best place would be the wall next to the oven, but it's only 1/8 inch thick. To bolster that, I put a 1/4 inch HDPE plate I formed on the back or opposite side of the wall, and then I screwed the compressor's mounting plate through the wall and into that. I used panhead screws and then found out later that that wasn't enough clearance to mount the compressor. They were sticking too far out from the plate. So I had to replace them with flathead screws. I like that the compressor secures into place without need for nuts and bolts. Easy to remove and replace. There are different configurations for these fridge units you'll find in these manuals, and you'll be able to identify pretty easily which instructions are for your model. But what's frustrating to me is why, with a fridge system costing well over $1,000, that Isotherm couldn't make a manual with better illustrations and these underexposed black and white photos. Anyway, I connected the wires of the digital display and the thermistor and the adaptive wiring to the terminal block on the compressor. The wires and terminals are well labeled, and you can follow these despite the underexposed photos. Okay, now it's time to connect the tubing to and from the compressor. This is not a fun job in confined space. Anyway, the instructions are easy to follow, and they warn you about using proper torque and proper wrenches when tightening tubing connectors. Well, I don't have torque wrenches, so I called them about this, and also about the lack of lubricant in some of the refrigerant tubing connectors. By the way, to reach somebody, try the non-technical help number. That's the way I reach somebody. Okay, regarding torque, they said to hand tighten the nut lightly with a wrench if you need to. Then, once it's snug, tighten the 1/8 inch turn further, while ensuring you hold the non-tubing, or rather the non-turning fitting, to avoid twisting the soft copper tubing. Now, in regards to lubrication, the manual states to make sure when you take the protective caps off of the connection fittings to visibly check for lubrication. But they didn't say what to do if you don't see it, and that's why I called them on this second thing. I didn't see it in 2 connectors. Indel Wabasco rep said it'll probably be fine, but don't use any lubricant on them that's not already there, as it can contaminate the refrigerant. Connecting the tubing was straightforward, but for me it was awkward in this confined space and slow, and you'll need to be careful to keep the fixed connector from turning. When connecting this line from the cold plate to the compressor, I heard a brief hiss, which I guess was the high pressure gas charging the line. To tighten the right amount, and also to foolproof my work in case I get interrupted, I don't want to come back to the same line and over tighten them, I marked the connectors with these 2 black lines. Okay, so now all the tubing is connected. The manual suggests that you save these protective caps for the connector fittings in case you need to disconnect the component for service or replacement. Supposedly, the fittings will not leak refrigerant while disconnected. Alright, after double checking the fittings and wiring, tucking wires away, securing tubing to keep it from vibrating, and then also getting it out of the way, I turned on the system. But I found one of these push-on connectors a little loose, so the system didn't come on immediately until I found this loose connector. But then the compressor came on, running at a high speed. Looks like we're running close to 6 amps there, DC amps. And it's programmed to do this when the cold plate is warm and you have sufficient power. After a few minutes, it'll slow down to a slower speed and draw only about 2 to 3 amps. Checking the cold plate, I could hear fluid going through it, and it was getting colder.
Yeah, I think it's starting to get cold. It's just been on for about a minute.
Okay, now that I know the fridge system works, I'll permanently install the through hull. I'll heavily coat the through hull and line the hole in the hull with Sitka 291. I suppose you could use 3M 4200, but Sitka was recommended by Isotherm in the manual, and I wouldn't use 5200 as there's a chance I might need to get this thing out one day if it needs repair, and there's more of a chance of that than, say, for a simple, more robust Grocco valve. What I'm installing at this point is a heat exchanger, not a valve. What's bothering me now is this crowded connector on the compressor, the module. And because, you know, earlier one of the connectors was not quite sitting well on its blade, and so it was a little loose when I started up the system. and after jingling it, it started running. But I don't think these connectors are particularly well suited for a marine environment. So I clipped them all off, and I installed marine grade connectors with heat shrink. Okay, now it's back to plumbing. After bending the refrigerant tubing aside, I applied a good layer of Rectiseal 5 on the threads to the ball valve. Tape's not recommended when sealing pipe over inch diameter. Unfortunately, this seems to be straight thread as opposed to pipe thread, and after screwing it all the way down on the through hole, the valve rotation stops, but with the valve handle on the opposite side of my reach. With pipe thread, I probably could have been able to avoid that. But now, although I've tightened the ball valve securely to the through hole, I'm not really happy about this non-pipe thread connection, since there's a possibility the valve could turn slightly and start a leak, although that's probably of low probability. Now I need to connect the waste tubing to the ball valve. That goes up to the sink. And where the plumbing is below the water level, I'll install these 3/16 stainless hose clamps, and they'll be on opposite sides. Next, I wanted to protect the compressor from water. Well, first, it's under a sink, and second, there's pressurized water lines nearby. So I built a drip shield made out of acrylic. First thing I did was cut out a form with this piece of cardboard. And once I got a shape that I liked, I went back with a heat gun to form a similar shape on the acrylic sheet I have. I'll show the first of 4 bins here in the shop. And finally, I cut circular holes. You'll see them here in the bottom of the shield to encourage ventilation around the compressor. And I mounted this shield over the compressor, and I did maybe more than I needed to. I made threaded stainless steel plates to receive thumb screws so that I could easily remove and replace this shield over time. Okay, so now the installation's done. Since I'm on the hard, or as I like to say, on the hard asphalt, I need to test through-hole for leaks and to enable the through-hole heat exchanger to work more efficiently, like with cooling water. Although this won't be totally like the real environment where water is able to slap in and out of the through-hole. I made this cap out of acrylic, bolted onto 3-inch diameter PVC pipe, and then I have a soft gasket here of neoprene rubber. I filled the galley sinks with water and found there were no leaks. And after several hours with the fridge on, it eventually reached an equilibrium in terms of cooling the icebox. And I find it comes on, maybe half or less of the time. And that's with a fridge temperature of 50, and the outside temperature is close to 90. The heat exchanger ranges between the mid-90s to about 105. I think I may have seen 109 at one point. I'd imagine it would be a bit lower, and the fridge run a little bit less often if the boat was on the water and that heat exchanger was working with its greatest efficiency. The manual is easy to follow for programming the unit. You'll want a thermometer to calibrate the thermistor that senses temperature in the icebox that I showed earlier, and that controls the compressor. The readout from the thermistor is what you see on the digital display. I found more than a 10-degree Fahrenheit difference between it and actual temperature. I bought this remote reading thermometer on Amazon for about $10. You'll find this offset adjustment and others like the battery protection selections in the secondary menu on the display that's accessible from the display unit. And instructions were clear on this. And that's a wrap on installing an Isotherm 3251 refrigeration system aboard our small sailboat. I hope you found that interesting and perhaps helpful for whatever project you may be on. Anyway, coming up, maybe a rudder project, or restoring the rudder, and also getting a gudgeon manufactured. That's a piece of hardware that attaches the rudder to the keel. We had some problems with that. Anyway, I'm not sure whether we're going to be talking about rudders in the next video or not. Depends upon how far along we get. In the meantime, we need to take care of a sailing itch. We didn't get out on Lake Superior this summer, so perhaps we'll take out our O'Day Widgeon sailboat for a little bit of sailing on a nearby lake. In the meantime, fair wind and following seas to you.